Hello, so in this video I'm just going to walk you through solving quadratics by factorization. I'm going to give you many examples. I'm going to give you 8 examples just so the whole methodology is drilled into your head. So remember, with quadratics, you know a equation is a quadratic if it has an x squared term in the equation. Okay? Quadratics are always of the form ax squared plus bx plus c is equal to 0. And this equals 0 part at the end is very important because we cannot do factorization, the method we're about to learn, if we do not have this equation being equal to 0. Meaning, if at any point you have an equation with an x squared term in it, let's just say x squared plus 5x, and then it's equal to something like 10, we're not going to be able to do our factorization methods until this equation is a quadratic being equal to 0. And what that means is this is then going to be rearranged so that we have that equal 0 at the end. And the way we do that is we just take this 10 over to this side. So if we subtract 10 on both sides, we'll have x squared plus 5x and then minus 10 because we subtracted it on both sides. And then because on the right hand side we did 10 subtract 10, it's going to be equal to 0. And then now, I'm not even sure if this quadratic can be factorized, but this is what I'm trying to get to, is that this now can then, our methods can then be applied to this side. Okay, so as long as it's equal to 0, we can apply our methods. So let's get into the examples just so we're not wasting too much time with this. So we have example 1. This is going to be x squared plus 5x and then plus 6 is equal to 0. So we're starting off easy. We've got the ideal situation. What we want to do is look for a number, two numbers that multiply to make 6 but add together in some capacity to make 5, which is the number in front of our x. And so what we have to do is look at the factors of 6. So if we go to the side and we look at the factors of 6, we have 1 times 6, so 1 and 6 are factors. Then we also have 2 times 3. We don't have any other pairings that do that. And now we're going to be looking at the pairs of factors to see which of these are going to add together to make 5. And we can see 2 and 3, if we take them to the side and say plus 2 and plus 3, these two are going to add together to make 5 because 2 plus 5 is 5, 2 plus 3 is 5, sorry, and also 2 times 3 is 6. And so both our conditions have been met. Two numbers that multiply to make your end number but add together to make the middle number in front of your x. And so because we're doing easy factorization right now, and easy meaning there's only a 1 in front of our x squared, we can straight away just write out 2 brackets like this. And remember, it's an equation, so it's still equal to 0. Now we put an x in front of both of them, and then we put our pairings, and we can put them in any order. This is going to be plus 2 and this is going to be plus 3. Okay? Now, one thing to remember, that now that we have 2 brackets, there's an invisible multiplication sign between the brackets. And so it's this bracket times this bracket is equal to 0. And if we have 2 numbers, let's say a and b, if we have a times b and they're equal to 0, we know that any number multiplied by 0 is 0. And so either a is equal to 0, because let's say b is 10, if we had 0 times 10, we'd get 0. And so either a is 0 or b is equal to 0. We don't know, right? We don't know the values of a and b, but what we can deduce from this equation, if we have 2 numbers multiplied by each other equaling 0, then we know that either this is 0 or this is 0. Okay? And this is the fact we're going to use. Let me make that a bit smaller and put it to the side. That's the fact we're going to use to solve for x here. Because if we have 2 things multiplied by each other to make 0, then either this is equal to 0 or this is equal to 0. Okay, and so I'm going to use that fact and say, okay, that means x plus 2 is equal to 0, or x plus 3 is equal to 0. And just solving linear equations, we know that if we have this being equal to 0 and we want x, we just subtract the 2 on both sides. So x is then going to be equal to, well, 2 subtract 2 cancels out, and then subtract 2. 0 subtract 2 is just minus 2. Or x is equal to minus 3 because we did the same thing. We subtracted the 3 over to that side. Okay, so this is the whole setup. You need to make sure you know how to factorize a quadratic before you try doing these quadratic solving by factorization questions. But once you know how to factorize, this is the next step. You take a quadratic equation, then you solve for the values of x. Okay, I hope that makes sense. So let's just go through as many examples as possible so that if you watch this video from start to finish, you'll be able to do this every single time. So again, we need to solve x squared minus 7x plus 12 is equal to 0. Okay, so first thing we do, this is like clockwork. We look for the factors of 12. So 1 times 12, 2 times 6, 3 times 4. What pairings are going to, in some capacity, add up to minus 7? Well, 1 and 12 can't do it, I know that. 2 and 6 can't do that. 3 and 4 can do that, because if you do 3 plus 4, you get 7. Remember, we want minus 7, but having a plus 7 is good progress. So now we have to think of what combination of 3 and 4 will make minus 7. And I can see that will be minus 3 minus 4, which is minus 7. But then we need to watch out with our negatives. We need to make sure that the numbers we have still multiply together to make positive 12. So minus 3 times minus 4, the two negatives, a negative times a negative makes a positive, and 3 times 4 we already know is equal to 12. And so minus 3 times minus 4 is equal to positive 12. Therefore, we got the correct pairings. So we're going to be using these. And again, we have nothing in front of this x squared. There's only a 1 there, a hidden 1. And so straight away to factorize this, we can just put 2 brackets out. Remember, it's an equation, so we're still equal to 0. We can put an x in front of both brackets. And then in any order, we can put a minus 4 and a minus 3. And again, either bracket is equal to 0. And so we can say x minus 4 is equal to 0, or x minus 3 is equal to 0. Therefore, x is equal to positive 4, or x is equal to positive 3. Okay, we did the same thing we did here, just in less detail. We factorized it. We then said either this or this equals 0, and then we solved these two linear equations to get our solutions of x. Okay, let's keep it going. So the next example I have is x squared plus 3x is equal to 10. Remember what I said at the beginning. If this equation is not equal to 0, then we need to rearrange it so that it is equal to 0. So this is a quadratic definitely because it has an x squared term, but it's equal to 10. So we want to take this 10 over to that side to make this equation equal to 0. And so I'm going to say x squared plus 3x minus 10, because I subtracted 10 from both sides. And then on the right hand side, 10 minus 10 is equal to 0. And so we have our equals 0. That's exactly what I mean when I say we must make it equal to 0. Now we do our factorization. So we need to get two numbers that multiply to make 10, but add together to make 3. So we have 10, 1 times 10, 2 times 5, and nothing else. Now remember, we never forget about the negative signs. I'm just getting the factors of 10, but we need to make sure we multiply to make minus 10 and add together to make positive 3. So I can clearly see that it's not going to be 1 and 10. It's going to be this, this combination right here. But what combination of this is going to give us positive 3 and negative 10? And that is going to be positive 5 and negative 2, sorry. Because if we have positive 5 and negative 2, that's going to add together to make positive 3, which is what we want, a positive 3. But because there's a positive and a negative, that makes a minus. So 5 times negative 2 is negative 10, and that's what we want. And again, there's nothing in front of this x squared, so straight away we can say x equals 0. In one bracket we can put a plus 5, in one bracket we can put a minus 2 equals 0. Then we can say x plus 5 is equal to 0, or x minus 2 is equal to 0. Therefore, x is equal to minus 5, or x is equal to positive 2. Okay? Hope that makes sense. Let's keep it going. So the next one is going to be x squared plus 8. Okay, there, let's do that. So x squared plus 8 is equal to 6x. Hold on a minute, this looks really different. Well, it's not, because as long as we have an x squared term, this is going to be a quadratic. And as long as it doesn't equal 0, we need to rearrange. And so we know that this is a quadratic, we know it's an equation, but we know it's not equal to 0. And so our brain should immediately tell us we need to rearrange this. How are we going to rearrange this? Just take this whole term over to that side. And so I'm going to be a bit more explicit here. If we want to subtract 6x from both sides, then what we're going to have is x squared minus 6x plus 8 is equal to 0. Okay? I put it in this order just because it's normally the x squared, then the x, then the term with nothing on it. But you could have easily just put that at the end if you really wanted to. But if you want to learn the method properly, highly recommend you always keep it in this order. But yeah, it looks a bit different, but all you do is go back to your fundamentals. It's a quadratic, it needs rearranging to equal 0. Let's do exactly what we always do. And now we have a quadratic equals 0. Look for the factors of 8 and things that add together to make minus 6. So if we have 8, that's 1 and 8, that's 2 and 4 and nothing else. I know that 2 and 4 in some capacity can make a negative 6. And so I can tell you that it's going to be minus 4 and minus 2. Minus 4 minus 2 is minus 6. And again, minus 6. And again, because it's a negative times a negative, minus 4 times minus 2 is positive 8. And so we've got both conditions met. And it's a simple quadratic, nothing in front of the x squared. Therefore, we can put two brackets out, x equals 0, and then minus 4 minus 2 is equal to 0. Either this bracket is 0 or this bracket is 0, so x minus 4 is equal to 0, or x minus 2 is equal to 0. Therefore, x is equal to positive 4, or x is equal to positive 2. Just rearranging those. Okay, so I hope you're following along with these examples. We have 4 more examples to do. Feel free to always go back in the video if you didn't quite get an example. But let's move on to example number 5. We have minus x squared plus 5x minus 6 is equal to 0. Okay, now the method I teach you is always oriented around nothing being in front of the x squared. And so even if it's a negative, we don't like the fact that there is a negative in front of the x squared. So we want to make this x squared positive. The way we're going to make this positive is we're just going to subtract everything from here and take it to the other side. And so what that's going to look like is, well, we're going to add an x squared to both sides, we're going to subtract a 5x from both sides, and we're going to add a 6 to both sides. And so because we did it on the left, we have to do it to the right as well. Exactly what we've done. We have to do it on this side, we do it on this side. And so what we end up with is we have x squared minus 5x positive 6 is equal to 0. Remember, all we did in order was we added the 6 to both sides, we subtracted the 5 from both sides, and we added the 6 to both sides. So just as we always do when we're rearranging, we have to do the same thing to one side to the other side. We just did that, but we did it 3 times because we have 3 terms there. So nothing crazy. And now we have nothing in front of the x squared, and we can easily look for the factors of 6. So let's look at the factors of 6. 1 times 6, 2 times 3. What combination makes 5? So we can look at 2 and 3. What combination makes minus 5, which is this? Well, that's going to be minus 2 minus 3, which is minus 5. And so we've got that. But do they multiply together to make positive 6? Well, negative 2 times negative 3 is definitely positive 6 because it's a negative times a negative. So we got both of those again. Therefore, double bracket x equals 0. We can put them in any order, minus 3, minus 2. Therefore, this bracket is equal to 0, or this bracket is equal to 0. X minus 3 is equal to 0, or x minus 2 is equal to 0. Therefore, x is equal to positive 3, or x is equal to positive 2. Okay, keep on following because we have 3 more examples, I believe. So example number, let's do example 6. So this is another negative one. So we've got minus x squared positive 7x is equal to 12. And I hope what you're getting from this video is that as long as we have an x squared and as long as we have an equal sign somewhere, we can always solve by factorization using our methods, as long as we stick to the foundations. We don't want anything in front of the x squared. We want it equal to 0. We just have to remember these foundations and then always take our quadratic and transform it to what we want. This again is a quadratic because it has an x squared term. We have a negative in front of the x squared. We don't like that. So what we're going to do is take this over to that side. And so I'm just going to do this a bit more slower than the previous example. Add an x squared to both sides. And so we're going to have 7x is equal to x squared plus 12. Now the x squared is positive, so we like that. But remember, we need to make it equal to 0. So we want to take this over with it as well. So we're going to subtract 7x from both sides. Subtract 7x from both sides. And then I'm just going to write the equation on this side because we're used to that. So we have x squared minus 7x plus 12 is equal to 0. Okay, so again, I've not done anything crazy. All I've done is taken this over to the other side, and then I've just put it in the right order, and then it's still equal to 0. And then again, we have 12, 1 times 12, 2 times 6, and 3 times 4. We know that 3 and 4 can make 7. Now we know that minus 3 minus 4 is equal to minus 7, which is what we want. And we know minus 3 times minus 4, negative times a negative is going to be positive 12, which is what we want. So again, brackets x is equal to 0. And then we can put minus 3 minus 4. Either this bracket is equal to 0 or this bracket is equal to 0. Therefore, x is equal to positive 3 or x is equal to positive 4. Brilliant. So moving on then, example 7. So we have x squared minus 25 is equal to 0. So let's think about this. It's a quadratic because it's an x squared term. It has an x squared term. And it's in the form that we want because it's equal to 0. There's nothing in front of the x squared. Perfect. Now this is a specific example called the difference of two squares. I'm going to run out of space. This is the difference of two squares. So as long as you have a number squared, subtract, remember the subtraction has to be there, another number squared, equals 0, or it doesn't even have to be equal to 0, but the point is, as long as we have a number squared, subtract another number squared, we can do the difference of two squares factorization. I'm just going to quickly write it out for you. As long as we have a squared subtract b squared, then we can just write two brackets straight away and put a, b, one has a plus, one has a minus. We can always do this, but it has to be a Square number, subtract a square number. And in this case, let's just use a different example just so I can show you it later. If we have x squared subtract 9, then immediately we can draw out two brackets because we know we have an x and then we have a 3. Why do we know it's a 3? Because we know that 9 is 3 times 3, i.e. 9 is a square number. And as long as we can identify it's a square number, then we know that we can reduce it to its square root. The square root of 9 is 3 because 3 times 3 is 9. Okay? Okay, so let's go back to this example then. So it's using this fact of difference of two squares to be able to solve this equation. Because now that we've identified that this is a difference of two squares, we can factorize it immediately. So we know we've got two brackets. We have x. 5 times 5 is 25. So we know we can put 5 here and 5 there. One has a plus, one has a minus. And because we've already done the factorization, that means x plus 5 is equal to 0, or x minus 5 is equal to 0. Therefore, x is equal to minus 5, or x is equal to positive 5. Okay? So as long as we can identify we have a difference of two squares problem, we can immediately factorize. And then once we've factorized equal to 0, we know that we can go down and do this solving for x. And then the final example I'm going to give you is, I've written down quite a difficult example, so I'm going to give you just an easier one. Let's say we have y squared is equal to 36. Y squared is equal to 36. So it has a square term in it, right? It doesn't have to be x. As long as it has a squared term in it, it is a quadratic. Now, we have a squared term. We don't have anything in front of it. And we want equals 0. Remember, we always want equals 0. And so this is equal to 36. Our goal is to subtract the 36 to the other side. So we have y squared subtract 36 is equal to 0. Now it's the difference of two squares. It's a quadratic, nothing in front of the y squared, but it has a subtract a square number. 36 is 6 times 6. And so immediately we can do two brackets. Put y in the front, and then we can put plus 6 and minus 6 because we know that 6 times 6 is 36. Therefore, y plus 6 is equal to 0, or y minus 6 is equal to 0. Therefore, y is equal to minus 6, or y is equal to positive 6. Okay, I hope all of those examples made sense. Yeah. If you have any questions, let me know in the comments. Otherwise, if you didn't understand any example, just scroll back and then try rewatching it, and then it should make sense. Okay, you take care, and I'll see you in the next one. Bye.